The OBASHI Foundation Course, Lesson 5, Elements and Layers. Welcome to Lesson 5. In this lesson, we're going to study OBASHI elements and layers in more detail. We'll start with elements before walking through the ownership, business process, application, system, hardware, and infrastructure layers one by one. Once the layers of the OBASHI diagram have been drawn, elements are added to them. These elements are the building blocks of a bit diagram. Elements represent an organization's assets or resources, whether they are physical or non-physical. Elements could, for example, be a role, an application, a server, or an operating system. Your organization might refer to elements as configuration items, entities, or artifacts. Elements are drawn onto the bit diagram as a rectangle. They might be manually hand-drawn or added using a tool. The length of the rectangle will vary, as you can see here, depending on how many other elements it links to. Some elements might even be squares. This is perfectly okay. Remember, OBASHI has 6 layers for an element to be placed within: ownership, business process, application, system, hardware, and infrastructure. Which layer an element is placed in tells us what type of element it is. Once an element has been placed within a layer, it becomes associated with it. This means it has its first relationship. An element in a layer is implicitly associated with that layer. Elements can be repositioned within a layer, but they cannot be moved to another layer. A system element can never become a piece of hardware. An application can never become a business process. Elements must be contained within their layer and cannot be resized beyond it. If an application element, for example, was resized so that it overlapped into the business process layer, it would no longer be clear what type of element it was. Once an element has been placed on the bit diagram, it will be given a name. For example, ownership elements might be named after business departments, such as the sales and finance departments. It's good practice to define a naming convention before starting to create bit diagrams, so that everyone understands exactly what is meant by a name and how an element should be named. One question that is frequently asked is whether an element can exist more than once on the same bit diagram. This is acceptable and is practical for a number of reasons. Firstly, repeating an element can make a bit diagram clearer, perhaps by simplifying connections between elements. Secondly, it can add context to a diagram by establishing additional relationships. Thirdly, this technique might be used to make the bit more visually arresting and underline a point. Can you think of any other reasons why an element might be duplicated on the same bit? If the technique is applied, each instance of the element must have a unique reference. We'll add a diagram to your study guide for this lesson that shows an example of multiple versions of the same element on one bit. Elements have some specific characteristics. An element type is dictated by the layer in which it is placed. An element in the application layer is an application element. An element cannot be connected to every other type of element. It can only connect to those in adjacent layers. No element can connect outside of its adjacent layer, so a hardware element can't connect to an ownership element. And finally, elements of the same type can connect together to form a hierarchical structure within a layer. For example, a hub, a switch, and a router might have a hierarchical relationship within the infrastructure layer. OBASHI defines colors for each element type. Using these standard colors allows OBASHI diagrams to be easily understood and shared, with everyone having a common understanding. Sometimes it will be necessary to add extra colors. For example, the hardware layer may have 2 colors of elements. One type of hardware could be owned by the organization creating the diagram, the other is leased from a third-party supplier. If extra colors are added, a legend needs to be added to the bit explaining what they mean and how they are used. The next area we need to consider briefly is the placing of elements on the bit diagram. The horizontal and vertical alignment of the elements has a meaning and helps to define the data flow, so their placement is very important. When we study the relationship rules in Lesson 6, we'll consider this in more detail. For now, it's important to remember that elements must be placed precisely in accordance with relationship rules, as this will help to make the bit diagram meaningful. Now that we've considered the placing of elements on the bit diagram, let's think about the layers in more detail. The layers are the framework that we organize elements within. Where the elements are placed provides a visual representation of their relationship with other elements. Let's consider an example. The bit diagram shows some of the relationships that are signified by the placement of elements within a layer. Here, the owner element type has been placed above the process element. This shows that the business process belongs to or is used by that owner. The business process is placed above an application, which shows that the process uses that application. Elements can be linked in a number of ways, including physical connections and dependencies. We'll study these in detail in Lesson 7 when we start to look at the OBASHI relationship types. Each element on a bit diagram can have attributes added to it, and can also be linked to supporting documentation. This provides context. For example, a hardware element type might have a support contract associated with it. A business process might have a formal document outlining the process steps, roles and responsibilities, and levels of authority. Once the bit diagram has been drawn and the elements have been placed in the layers, the data flow is superimposed onto it. This flow shows which elements support a particular business process or service, as we learnt when we considered the data flow analysis view. A library of bit diagrams can be built up to give a complete picture of the organization, including the people, processes, and technology that make it work. We're going to complete this section with a recap of some of the important facts about elements. We'll start with a recap on the positioning of elements. Remember, elements are placed within their own layer and cannot be resized beyond it. Elements are named according to a defined naming convention. There can be multiple instances of an element in a layer. The color of the element is important, and non-standard colors need to have a legend. Elements need to be placed precisely, as their horizontal and vertical alignment provides information about relationships with other elements. And finally, elements can be arranged hierarchically as well as according to spatial relationships. We also need to recap the guidance related to multiple occurrences of the same element. An element can exist on more than one bit diagram, but it can also be shown more than once on a single diagram, as you can see here with the SAP, Oracle, and Siebel elements. This multiple placement makes the diagram easier to use and the data flows easier to map. These multiple elements refer to the same underlying asset. It doesn't mean the organization has 3 installations of Oracle. Modern business processes and the IT that supports them can be very complex, so this is an efficient way to model real-world scenarios. Next, we're going to study the layers one by one. You can see a reminder on screen now. We'll start at the top with the ownership layer. The ownership layer is used to show which person, role, or group has the ownership of the process or processes shown in the business process layer. By ownership, we might mean that the person, role, or group uses the process or is responsible for the process. So the finance director might own the invoicing process. The warehouse group might be responsible for the order picking process. Ownership type elements are placed above the processes they own or use to show the relationship. OBASHI defines 3 categories of owner. Personnel. This could be a person or a job title or role. Location. This could be an office, a building, or a place name. Organizational unit. This could be a department, group, team, or budgetary entity or cost unit. The ownership layer helps to identify the people, teams, and locations who are stakeholders in the business process. This information has many uses, which we're going to consider with an exercise. Plan to spend 15 minutes on this exercise, and don't forget to check your study guide for suggested solution. OBASHI helps to identify the owners who are responsible for or use business processes. Document 5 reasons why this information is useful and important. For example, it might help us to understand who is affected by the failure of an IT element that supports the process. Within the ownership layer, the elements can be stacked to create a hierarchy, as you can see in this diagram. Jane Smith has overall accountability for the business processes underneath these elements. This includes 2 locations, Data Center 1 and London, and 2 organizational units, Accounts and Logistics. Accounts is subdivided further into the CapEx and OpEx units. The way these elements are placed has a specific meaning and helps to provide context to the bit diagram. Using the structure, it is easy, for example, to show organizational reporting structures and levels of management. Underneath the ownership layer is the business process layer. This is where the business processes or functions used by the owners are placed. Each business process is placed underneath its owner. For example, the payroll and financial reporting processes might be placed under the finance director. Defining exactly what we mean by a business process or function can be challenging. Definitions need to be agreed at the start of the OBASHI project to make sure the scope of the bit diagrams is correct. Business analysis defines a business function or business process as a set of logically related activities which create a definable result when performed together. Business processes often break down into other smaller or sub-processes. For example, payroll might break down into time recording, time validation, salary transfer, and reconciliation processes. Remember the 3rd rule of digital dynamics. A digital flow can consist of one or more digital flows. A high-level business process will be broken down into other smaller business processes. This breakdown will continue to the level required to support the OBASHI project. The lowest level of breakdown will be the smallest tasks, which produce a definable result for the business process when performed. Beyond this level, the process does not need to be broken down any further. The tasks that a process is broken into form a set of workflows. When the workflows are carried out, they deliver the end-to-end business process. The business process elements on the bit diagram can be high-level processes or low-level tasks. A number of business process elements can be placed in a hierarchy, for example, to show how a high-level process is made up of lower-level processes. You can see an example here. The accounting process includes invoicing and payroll, and invoicing includes invoices received and generated. Accounting is the higher-level process. The element is stretched and resized to show that it has a relationship with the other elements. In this way, OBASHI shows the business process and the activities that fulfill it. Processes can be modeled to sub-process level and all the way down to individual tasks. Trying to put too much information on one bit diagram can defeat the purpose and lead to confusion. A good practice approach for complex business processes is to create a high-level bit diagram for the business process, and then lower-level bit diagrams that show the lower-level processes and workflows. This decomposes the process, allowing the right level of detail to be shown to the right audience. Element sizing is useful when adding elements to the business process layer. Accounting is a high-level process here. We can see this because it is wider to cover the elements underneath it. Higher-level elements will have broader definitions. Lower-level elements, such as invoices received and generated, have a narrower scope. This can be seen visually on the bit, as the element is drawn as a narrower shape. These visual clues add granularity to the diagram. The more granular detail we have, the more business context we have, and the better any decisions based on the bit diagram will be. The application layer sits beneath the business process layer. Most business processes in a modern organization rely on applications to generate, record, store, and access information. Think about your business processes. What applications do they rely on? The application layer includes elements that represent software applications or define parts of software applications. For a large enterprise resource planning application, it will be useful to have elements for areas of functionality, such as human resources and management accounting, rather than a single element that represents the whole ERP system. This could also be represented by a hierarchy of elements. Application elements sit beneath the business processes they support. By adding the elements to the application layer, an organization creates an application portfolio showing all of the applications in use. These applications can be linked to their stakeholders, and information can be extracted for reporting and license management. Any redundant applications can be identified and removed, leading to cost savings and a less complicated estate to support. The systems layer is used to represent operating systems. These elements are shown above the hardware they are installed on, and below the applications they support. OBASHI distinguishes between applications and operating systems. This allows organizations to quickly and easily analyze their OS deployment and licensing position. You can see some examples of operating systems here. Beneath the operating system layer, there is the hardware layer. The elements here represent the hardware that the operating systems run on. For example, an operating system element might be placed above a server element, showing the relationship between them. You can see some examples of hardware elements here. Hardware may also include non-network items like printers. By populating the hardware layer, an organization creates an asset register of items. This will have links to IT service management processes like asset and configuration management. Hardware items can be physical or logical. A logical item could, for example, be a virtual server. A hardware element might represent a single item like a printer or a group of items like a blade server. The blade server has multiple blades, which can be shown as separate elements or grouped together. OBASHI provides a way of documenting this that shows each blade is separate and redundant, as you can see here. The bottom layer of our bit diagram is the infrastructure layer. This layer shows the network infrastructure elements, with elements placed beneath the hardware elements they are related to. Infrastructure hierarchies are created, for example a router and a switch, by placing infrastructure elements on top of or beneath each other. OBASHI creates flexible bit diagrams that can be used to map any network design or configuration. Populating the infrastructure layer creates an asset register of all the network equipment in the organization. Failure of a network element can have a critical impact on a business process, so accurate mapping at this level is very important. Vulnerable elements can be identified in the data flow analysis view, and cost-justified decisions can be made about implementing redundancy. Many organizations use network equipment from a number of proprietary manufacturers. Colors can be added to the infrastructure layer to show which manufacturer each element is linked to. But remember, you will need to add a legend as well to explain what the colors mean. The infrastructure layer can be used to map the impact of downtime, and can also highlight potential security issues. Common infrastructure elements include switches, routers, bridges, and hubs. Wireless network equipment and modems would also be classed as infrastructure elements from an OBASHI perspective. If there is any confusion about which layer a piece of equipment should sit within, the organization needs to make a decision, then document it and communicate it to all stakeholders involved in the OBASHI project. Let's finish this lesson with another exercise. Plan to spend 15 minutes on this exercise, and don't forget you'll find the suggested solution in your study guide. The OBASHI layers are ownership, business process, application, system, hardware, and infrastructure. Give 5 examples of elements for each layer. For example, hardware elements might include servers.